Hey, can you explain JVM architecture? I tried, but it's too confusing.
Okay, listen carefully. Think of JVM like a factory with different sections: class loader, runtime data area, execution engine, JNI, and native libraries. First, class loader. It loads classes into memory when they are needed. When your program starts, the main class is loaded first, and execution begins from there. Then, when JVM sees that you are creating a new object, it loads that class at that moment. So the flow becomes: main class loads, execution starts, object is created, then the required class loads. This is called dynamic class loading. There are 3 types of class loaders: Bootstrap class loader loads core Java classes, extension class loader loads external libraries, application class loader loads your code. Java follows something called parent delegation. Your code first asks higher-level class loaders and only loads the class itself if no one else can. This is done for security. Imagine someone tries to create a fake core class, like string. JVM will not trust that version. It first checks trusted core libraries and loads the real one from there, so fake classes are ignored, and core Java stays safe. Class loading has 3 phases: loading, linking, and initialization. In loading, the class enters memory and JVM creates its representation. Linking has 3 parts: verification checks if your code is valid and safe. If something is wrong, execution stops. Preparation creates memory for static variables, but only default values are assigned. Resolution connects all references to actual memory locations. Initialization assigns the actual values, and static blocks run. Now, memory inside JVM. Method area stores class-level information like class details, methods, static variables, and constants. Heap stores all objects created during runtime. When you create an object, it goes into heap along with its data like variables and arrays. Strings are also stored here in a special area called string pool. Each thread has its own stack. It stores method execution details. Whenever a method runs, a new stack frame is created. It stores variables and references. When the method finishes, that frame is removed. Program counter register keeps track of which instruction will run next. Native method stack is used when a thread calls methods written in languages like C or C++. Each thread has its own native method stack to manage those calls. Execution engine actually runs the code. Interpreter executes code instruction by instruction and converts bytecode into machine code. Jet compiler improves performance. If some part of code runs again and again, it converts it into machine code and keeps it, so next time it runs faster. Garbage collector cleans memory. When an object is no longer used anywhere, it becomes unreachable and is removed from memory. Sometimes Java needs to interact with the operating system or use low-level features. So it uses JNI to talk to native libraries, which finally interact with the operating system. Java code calls JNI, and JNI interacts with native libraries. These native libraries perform tasks like hardware access, operating system operations, and other low-level work. That's how everything inside JVM works, step by step.
You didn't just explain it. You made it feel simple. I think I just needed you to understand Java.